So Schrodinger does the wave equation, right? And the wave equation is a fancy three-dimensional y equals mx plus b. And if we think about that y equals mx plus b, each of those things represents something else, right? Like that's how up and down you are. That's how left and right you are. That's the slope of that. And this is where you cross the y-intercept kind of thing, right? Those each give us a different picture of, excuse me, a different part of the picture, right? That's the picture. The line is the picture. Well, these things give us a different picture of where the orbitals are that the electrons are in, right? So Bohr's model is this like planetary model kind of. It's the Jimmy Neutron model. It's the one that we draw most of the time. And it works for a lot of things, right? Like we've talked about a couple other models where if it works 90% of the time, well, great. 90% of the time, use that. But we do want a little bit better understanding as chemists and stuff, right? So, so this is where the orbitals actually are. So we don't know that this is right, but this has been around for about 100 years and been unchanged. So if a model hasn't changed in 100 years, it's probably pretty accurate, right? I know these are kind of hard to read, but they're the same as what's on your worksheet, so you can just kind of follow along on there, right? So the shape of our orbital, I'll run through each of those first, and then we'll run through the rest of it. So the shape of the spherical orbital, or of the s orbital, is just spherical. The s does not stand for spherical; it stands for sharp. But it's a sphere, right? Not a circle, but a sphere. So you might make note of that, right? The p orbitals are shaped like a dumbbell kind of thing. This is one orbital. This is not two orbitals. It's got two lobes, but it's one orbital, right? So it's usually called the dumbbell shape. So it's it looks, something like that. Basically, if you take the s orbital and twist it into like a figure eight sort of thing, that's this. The same thing then to get to the D's, if we took those and twisted those, I don't have that many balloons. I've run out of balloons, but it's a D thing. It looks like a four-leaf clover. A D orbital has four lobes. So basically like this, but then it's doubled up on the bottom. It's got two more. And then F, it stands for fundamental, actually, but I pretend it doesn't, but I pretend it stands for flower because it kind of looks like a flower. The only way I can draw it is I draw a little cube. And let's see, the dot's there. No, I'm supposed to be using dotted lines back here. There we go, right? Put a dot in the middle and then make one lobe to each one of the corners, right? Because there are 8 corners on a dice or on a cube, right? And so it's something along those lines. It's awfully ugly, right? I'm never going to ask you to draw it, but knowing that it's 1 lobe, 2 lobes, 4 lobes, 8 lobes, that kind of thing, right? Now, the electrons in each orbital. So this is the orbital. It's not an electron. It's the orbital that the electrons are in. And not only, like we talked about in the other video, are electrons waves, they also spin. And we know they spin because there's magnetic things and stuff, right? And that comes from electrons spinning. If you've had an MRI, they actually make the electron spin one way and they flip them and make them spin the other way, right? And so then they can read that. So there's 2 spins. It can have an up spin or a down spin. So that means there's room for 2 electrons in this little s orbital. One electron can have an up spin and 1 electron can have a down spin, right? So then there's those. So that means there's room for 2 electrons in that orbital. In a p orbital, in this orbital, there is also only, if one has an up spin, the other one has to have a down spin. Well, there's no other directions besides up and down as far as spins of electrons goes, right? So that means it can only hold 2 electrons in those orbitals. And in the d orbitals, even though there's 4 lobes, there's still only 2 electrons that can fit in that orbital. And in the f, there's only 2 electrons that can fit in that orbital. But there's multiple ways we can hold some of these orbitals. There's only one way I can hold a sphere, right? And that's this way. So there's only 1 orbital in this sublevel. Now, when I go further down on the periodic chart, I can have a 1 energy level S, or I can have a 2 energy level S, right? So that's bigger. I actually put a little balloon inside here. I thought you'd be able to see it, but you can't really see it in the video. You can kind of see a shadow maybe a little bit there. Yeah, you can kind of see it rolling around there, right? But you can have, as atoms get bigger, they get more layers, and you can have multiple layers. But in each sublevel, there's only 1 s orbital, which means you can hold a total of 2 electrons. There are 3 p sublevels. or sorry, three p orbitals in a p sublevel. There's the px, which would be like this. Whoa, my balloons fell apart. Uh-oh, don't tell chemistry clown college. They'll kick me out of chemistry clown college because my p orbitals fell apart. You can have a px, which is like this. You can have a py, which is like this. And you can have a pz, which is like this. So there are three, right? There's the px, which I'll just kind of draw them here. That's supposed to be a sideways. There's a px, a py, and a pz. And that's like coming in and out of the board is what that's supposed to be showing, right? So there's three p orbitals in a p sublevel. Well, if each one can hold 2 electrons and there's 3 of them, I can hold 6 electrons, right? Just 2 times 3. 2 electrons in each orbital, 3 orbitals in a sublevel, 6 electrons in a p sublevel. D, there's actually 5 different ways I can do that. That's complicated. I wouldn't worry about it too much on the different ways we can hold it and stuff, but there are 5 different ways we can hold it. So if there's 5 different p orbitals in a p sub, too many words. There are 5 d orbitals in a d sublevel, so that means overall you can hold 10 electrons, right? And if we follow the patterns here, right? Do we see patterns? Chemistry is all about recognizing pattern stuff. 1, 3, 5, 7. There are 7 ways you can hold d orbitals, and that means you can fit 14 electrons in a d sublevel. And we will be dealing with this a good bit. So that is something that's good to just know and have those have that table filled out and all that kind of stuff, right? So these are the orbitals. As the atoms get bigger, they fill those orbitals. So this is just a more accurate picture than like the 288, right? Because that 288 really only works for the first few electrons. Well, 2, well, that was just an s orbital. 8, well, that was an s orbital and a p or an s orbital and a p sublevel together, right? And then 18, that's an s, a p, and a d, right? So that's the other one was just kind of overly simplified as to what's really there.